Solving linear equations using graphical techniques. So we've been looking a lot at these equations or graphing straight lines, and a rule for a straight line really just shows the connection between the x and the y coordinates of each point on the line. And we know that because we've drawn up tables of values and substituted in x values to find y values and use that to draw a straight line. So have a look at this line here. I've drawn the line y equals 2x minus 1. So I'll write that down, y equals 2x minus 1. And say I said to you, I want to know whether this point 2 and 3 lies on the line. Now, you can say to me, yes, it does, because I can just see that. The point 2, 3 does lie on that line. But if I asked you to show it to me or to prove it, I'm going to show you a technique that you need to be able to follow. So the first thing I'd like you to think about is your point is made up of an x value and a y value. And the other thing is I've got an equation of a line, and on my equation of the line, I look at the left-hand side of the equal sign and the right-hand side of the equal sign. Now, if I look at the left-hand side of my equal sign, I just have the letter y. And from my point, I know that the value of that is 3. So my left-hand side is 3. Now I'm going to look at the right-hand side of my line, and that is 2x minus 1. And from my point, I know that the x value should be 2. So I'm going to substitute that in. 2 times 2 is 4, minus 1 gives me 3. And now I can say, well, left-hand side equals right-hand side. Therefore, the point 2, 3 lies on the line. And I'll name that line y equals 2x minus 1. That's the first thing. Now, a little problem-solving activity. I'd like you to pause the video and have a go and see if you can do this without any help. And I've said, when a value is substituted into an equation and it makes the equation true, left-hand side equals right-hand side, then that value is a solution to that equation. And for the first part, from the list below, match each equation with a solution. Some equations may have more than one solution. So we have equations here, possible solutions on this side, and I'd now like you to spend probably 5 minutes seeing if you can find solutions, using those solutions, and seeing which of those solutions could possibly belong to those equations. Pause the video now and come back after 5 minutes. Now, some answers to this. Which two equations share the same solution, and what is that solution? Well, I have y equals 10 minus 3x, and I also have y equals 2x minus 5, and they share the same solution, which is the solution 3, 1. Meaning, when I substitute x equals 3 into both of those equations, we get the y value is 1. List the equations that have only one solution. So the equations that have only one solution are 2x minus 4 equals 8, 3x plus 2 equals 11, and 5x minus 3 equals 2. And what's a common feature? Well, they have only one pronumeral. And remember, a pronumeral is the letter part. They all just have an x, and they can be solved to find the value of x, which is one solution. List the equations that have more than one solution. Well, I've got y equals 2x minus 5. I've got y equals 10 minus 3x. And I've got y equals x plus 4. And the common feature of these ones that have more than one solution is that they have two pronumerals. They have an x and a y, meaning if you have a value of x, you can find an infinite amount of values of y because you can choose an infinite number of values for x. The next thing in this section I'd like you to understand is a point of intersection, and it's probably the easiest thing we're going to do. The point of intersection is here, the point where two lines cross each other. And we've done a lot of work on reading points, and you can see that the value of this point would be 1 and 3. So a point of intersection is where two lines cross each other. Another thing we need to be able to do is to be able to solve equations graphically. And that sounds a bit strange because you all know how to solve equations normally. So for example, I've got 2x plus 1 equals 5. You all know to subtract 1 from both sides and you would get 4. And you know to divide by 2 and you would get x equals 2. But we can also solve this graphically. 2x plus 1 equals 5. Here, my y value is 5. So I'm going to go up here to where y is 5, and I go across until I touch my line, and I come down and read off what I get, which in this case is 2. So the x part of that is 2. Now I'm going to do the same for the next one. The y value is now 0. Y is 0 here. I go until I hit my line, and here is where I'm hitting it, and I'm thinking to myself, what is that x value? That is where x is negative a half. And I'm going to do the same for negative 4. Now remember, this is your y value because my line could be in the form y equals 2x. 2x plus 1 equals y. But y now is negative 4. So I go to my y-axis till I get to negative 4. I go across until I hit my line. And I come up and read off what that is. And that gives me the x value of minus 2.5, or you could have written it as minus 2.5. I'm happy with both. So that's a way of solving an equation without having to work it algebraically. We are solving it graphically. And the last thing we have to do. Use the graphs of y equals 4 minus x and y equals 2x plus 1 shown here to answer these questions. Write two equations which each have x minus 2 as a solution. So I'm going to where I see x is minus 2. Here it is. If I go up here and hit this axis, I hit my line and go across and read off, I have 6 here. So an equation could be, instead of y equals 4 minus x, I could say 6 equals 4 minus x. And you know that if you solved that, you would still get x equals negative 2 as a solution. Now I'm going to do the same for the other line. I'm still at x equals minus 2. I'm going down till I hit the other line, and I'm going to read across what the y value is. In this case, negative 3. So I write this now. Instead of y equals 2x plus 1, I'm going to say negative 3 equals 2x plus 1. Write 4 solutions in the form xy for the line with equation y equals 4 minus x. Well, 4 solutions, the line 4 minus x. That means I could just write off any points that are on this line. So some possible solutions could be the point 2, 2, minus 1, 5, minus 2, 6, 4, 0, 0, 4. And question part C is exactly the same with a different line, with our line y equals 2x plus 1. Pause the video, see if you can do it without my help. And for those that were unsure, I'm just finding points along my line and writing them down. So here I could have done -2, -3. I could have done -1, -1. I could have done the point 0, 1, 1, 3, 2, 5, any points that lie on the line. Write one solution xy that is true for both lines and show that it satisfies both line equations. Well, what is the solution that's true for both lines? It's really asking us for that point of intersection. Here is a solution that is true for both lines. It is the point 1, 3. It's a point that lies on both lines. And show that it satisfies, when I see that word show that, I'm going to take one of my lines and show you, and you can do the next one. To show that means I need to do that left-hand side and that right-hand side work. So going through it again, because it was a while ago we just did it, left-hand side, right-hand side, and my point is x is 1 and y is 3. For my left-hand side, I've got 3, because I just have y. For my right-hand side, I've got 2x plus 1, and that's going to be 2 times 1 plus 1. 2 ones are 2 plus 1 is 3. Left-hand side equals right-hand side, so the point 1, 3 lies on it. And then I'm going to do the same for the other one. The other line, which is the line y equals 4 minus x. Y equals 4 minus x. Left-hand side equals y, which is 3. Right-hand side equals 4 minus x, which is 4 minus 1, which is 3. Left-hand side equals right-hand side, so the point 1, 3 lies on that line. And the very last thing, solve this equation. Well, have a look at it. You could solve it, but I can see here is one of our straight lines that we've drawn, and here is the other straight line, and I just need the x component of it. And we've already got the point of intersection, so the point that satisfies that, which is the solution to that equation, is the point x equals 1. Thank you for watching.